Welcome back to the cost variance videos. This is video 2. In this video we're going to be talking about material cost variance and setting up a labor cost variance problem, but not solving it. In the last video we talked about an introduction to cost variance, so if you haven't seen that yet, go ahead and take a look at it. But we'll start right away with material variance. The yearly budget for the black polypropylene pieces in a Rubik's Cube, back to the Rubik's Cube example, is $177,000 when the forecasted production quantity for the year is 1 million Rubik's Cubes. After quarter 1, a variance analysis is completed on the material costs. The supplier increased the price of polypropylene from what we budgeted, so the real price per pound was 60 cents. The total production quantity for the quarter was 247,500. Using 84,150 pounds of polypropylene. So what we want to find here is the material price variance, the material quantity variance, and then the total material variance. So I'll start off first at the bottom left-hand corner. This table has some of the standard quantities and prices that we got from the standard costing videos. The 50 cents per pound is from the standard cost video for the Rubik's Cube, and the standard quantity of material of 0.354 pound per unit also comes from that standard cost video. The way that 86,625 pounds was created was by multiplying the 0.354 times the actual quantity produced of 247,500 units. With cost variance, we're always looking at the actual quantity, because if we have actual prices, we want to, or actual data, we want to be comparing for the actual produced quantity. So we multiply by the actual produced quantity, and that gives the 86,625 pounds. The actual price is given in the problem, 60 cents per pound, and this 84,150 pounds is given in the problem, divided by the actual quantity produced of 247,500 gives that 0.340 pounds for your actual quantity. So that's how those numbers were derived. So I'll explain this image to you. I told you you'd see it again. Essentially, we have two different U-shapes. The U-shape on the left is the price variance equation U-shape. The equation on the right is the usage variance equation U-shape. Those are the two different types of cost variance that we're looking at. So for price variance, what we want to understand is keeping the quantity constant. What is the difference between the standard, what we budgeted, and the actual, what we truly saw? So we do standard minus actual times that constant quantity. For usage or quantity variance, what we want to understand is, now keeping the price constant, what's the difference between the budgeted quantity for the actual units produced and the actual quantity of material that we used for the actual units produced. So those are the two equations that we have, and we can see exactly how they play out here. So one more time, the price variance, we are keeping this actual quantity, the 84,150 constant. We're taking the standard price, 0.5, subtracting 0.6, multiplying by our constant AQ purchased, and that gives us a negative or an unfavorable amount, 8,415. And that makes sense, right? Because we budgeted paying 50 cents, but we really paid 60 cents. So that's not going to make us happy. That's unfavorable. With our usage variance, we took the standard quantity of the actual units produced, that 86,625, subtracted the actual quantity used, 84,150, and multiplied by the standard price. And that gives us a favorable variance of about 1,200. And that makes sense also because we have that standard of 86,000 and the actual of 84,000, which means that we budgeted more than we actually used. 8,000 unfavorable and that 1,200 favorable gives us about 7,177 unfavorable, and that makes sense. Moving now to labor variance for a Rubik's Cube. It's very similar to the material cost variance. So I will read the problem, help you set it up, but there will be no solution at the end of this. This is something that you should pause the video, or the video is going to end. Let the video run out and do the problem by yourself. So the actual cost of labor for quarter one averaged out to be $8.50 per hour, and the actual direct labor time per unit is 12% lower than predicted. Remember that the production quantity is 247,500 units for the quarter. So your hint is that 5 minutes was the expected labor time. The actual time is 12% less than that. So maybe there was some sort of process improvement technique that was used and it lowered our time. And that seems like it would be a good thing. So for Q1, calculate the labor rate variance, the labor efficiency variance, and the total labor variance. So starting again at our table, we have our production quantity. Our standard price of labor is a number that was given to us by a previous video, $8.47. Our actual price is $8.50. Our standard quantity, so time per unit, is 5 minutes. And our actual quantity is something that you're going to have to figure out by yourself, 12% lower than that. So the price variance is known here as the rate variance. What we're trying to figure out is, again, keeping quantity the same, what's the difference between the standard price that we paid for labor, or that we budgeted paying for labor, and the actual price that we paid for labor. Standard is always first in the equations. For efficiency, we're keeping efficiency as a usage variance. We keep the price the same, and we're looking at what the difference between the standard quantity of labor for the units produced, the difference between that and the actual quantity of labor for the units produced. And from there, you should be able to figure it out. So good luck.